Hello everybody, my name is Ashutosh Sharma and here today I am making a video on quantitative techniques for manager subject, especially which is being designed for PGDM students. But let me tell you that quantitative techniques nothing but these are the statistical techniques. It is all about statistics. So those students are studying statistics in their graduation or as well as in their masters, so those students also can take benefits from this video for their learning purposes. In this video, we will discuss about that what is statistics, what are the applications of statistical techniques in business and economics. We will discuss about the data, what are the data sources, and further we will discuss about the measures of scales also as well. Now, move further. First question comes that what is statistics? So statistics can be defined in two senses. One in plural sense. In plural sense, when we are collecting data from the different people or like from different sources, so in that situation, that data is called as statistics in plural sense. And when we take all the techniques of statistics for collecting the data, for compilation of the data, thereafter making analysis of that data, then interpretation of that data, and then making conclusions from that data. So this whole process is called as statistics in singular sense. So I hope that you have got what is statistics. Let's move further. If we discuss about the application areas of statistics, though there is no area where statistical techniques are not being used right now. In nowadays, because research is an integral part of all the areas, that's why it is mandatory in all the areas to make use of statistical techniques. Though I have mentioned few of the areas like marketing, production, finance, investment, purchase, accounting, banking, control. Further, we may include medical science, agriculture, all the areas. You take the name of any area, and I can give you an example that in all the areas, definitely we are making use of statistical techniques. Now, uh, data. Data is nothing but these are the facts and figures which we collect, summarize, analyze, and interpret, and after that we conclude something. So data doesn't mean that only information which is kept and we are not making use of that information. Data is a scientific term in which we collect the data, we summarize and analyze and interpret, and we conclude something from that information. Then it is called as data. And for a particular situation, for a particular study, when we have collected data, that is referred as the data set. Let's move to the next slide. Okay, uh, here to understand that what are the elements, what are the variables and observations, because these are the terms which usually we make use in when we are studying statistics. So if we talk about elements, these are the entities on which data are collected. For example, suppose you are taking feedbacks about your services or about your products from the respondents. So each and every respondent or your customer who is providing you information or giving feedback of your services would be considered as an element. Further, if we talk about variable, variable is a characteristic of interest for the element. Like if you are, uh, I just have given you an example of collecting information about the feedback. So the questions you have included in your questionnaire regarding the feedback, so those questions would be considered as variables in your questionnaire. Okay, so the set of measurements collected for a particular elements is called an observations. So the values which respondent will provide you against the question which you have asked will be considered as observations. And if you want to calculate the total number of observation, it is very simple to calculate. Multiply the total number of elements with the number of variables and you will get the answer of total number of observations. Here I have taken an example where 5 stock exchanges of 5 different companies I have taken, and these stock exchanges we can call as elements and the characteristics on which we want to collect the data are annual sales in $1,000,000, earning per share in dollars. So these two are the variables, and the values of these variables for different exchanges, stock exchanges, are the observations. So I hope that with this example easily you would have understood that what are elements, what are variables, what are observations, and in this particular situation this data would be considered as data set. Okay, the very important aspect of statistics is to understand what are the different measures of scales, because ultimately whenever you are going to apply any of the statistical technique, it it is important to know that what kind of information, what kind of data you have collected, what kind of scale of measurement you have used to collect the data, because only you would be able to apply appropriate statistical technique. So there are 4 types of measures of scales: nominal, ordinal, interval, and ratio. And what do you understand by scale? The scale determines the amount of information contained in the data. The scale indicates the data summarization and statistical analysis that are most appropriate, as I told you. By knowing so that what kind of information you have collected, you would be able to understand that which appropriate statistical technique you should apply. So that's why these 4 types of measures of scales are very important to understand. Let's move to the next slide. First comes nominal scale. So nominal scale is simply a system of assigning number, symbols to events in order to label them. The usual example of this is assignment of numbers of basketball players in order to identify them. Such numbers cannot be considered to be associated with an ordered scale, for the order is of no consequence. The numbers are just convenient labels for the particular class of events and as such have no quantitative value. For example, labeling man as 1 and woman as 2, which is the most common way of labeling gender for data recording purposes, does not mean that women are twice something or other than men, nor it suggests that men are somehow better than women. We can take more examples. If you are collecting data about the gender of the respondents, you would simply ask that what is your gender? They will answer male, female. If you are asking about the likings or dislikings, they may say yes or no about likings. So such kind of information, such kind of data we are collecting is at nominal scale. If we talk about the characteristics of nominal data, so in statistics, nominal data, which is also known as nominal scale, is a type of data that is used to label variables without providing any quantitative value. It is the simplest form of a scale of measure. The only measure of central tendency for such data is the mode. So whenever we collect the information on nominal scale and we want to find out average value, which we call as measure of central tendency of the data, we can apply only mode. We can find only mode. We cannot apply mean or median or any other like harmonic or geometric mean on nominal data. So that's why I told you that appropriate technique would depend that what kind of data we have collected, on which scale we have collected the data. So in case of nominal data, only mode can be applied. Next is they may include words, letters and symbols. Name of the people, gender and nationality are just a few of the most common examples of nominal data. Although nominal data cannot be treated using mathematical operators, they still can be analyzed using advanced statistical methods. For example, one way to analyze the data is through hypothesis testing. Definitely, in nominal data, we cannot find variance or dispersion. We cannot apply correlation or regression. We, but still, we can test the hypothesis. What kind of hypothesis? To test hypothesis testing about nominal data, we make use of chi-square test, which is a non-parametric test. So here, yes, definitely we can test the hypothesis about the association between two nominal variables by making use of chi-square test. So this was all about nominal data. Let's move further. Here I have given you some examples for the better understanding of nominal data. Okay, now second type of measures of a scale is ordinal scale. Here one more thing I want to mention here, that in nominal data, none of the basic mathematical operators like addition, subtraction, multiplication and division, we were not able to apply any of these mathematical operators. Still, in ordinal scale, also we would not be able to apply any of the mathematical operators, non like addition, subtraction, multiplication, and division. But in ordinal scale, value can be numerical, and those values can be arranged in descending or ascending order. Okay, so let's try to understand it in better way. The ordinal scale places events in order, but there is no attempt to make the intervals of the scale equal in terms of some rule. Rank orders represent ordinal scales and are frequently used in research relating to the quantitative phenomena. A student's rank in his graduation class involves the use of an ordinal scale. One has to be very careful in making a statement about scores based on ordinal scales. For instance, if Ram's position in his class is 10 and Mohan's position is 40, it cannot be said that Ram's position is 4 times as good as that of Mohan. One more example we can take. In a fast food home delivery shop, those wish to ask its customers how would you rate the service of staff. They can give you excellent, if you can denote it by 1, very good, which again you can assign you can denote by 2, good 3, poor 4, worst 5. Similarly, you can assign the numbers in reverse order as well. Like you can assign 5 for excellent, 4 for very good, 3 for good, and 2 for poor, and 1 for worst. It is up to you, up to the researcher, that how he or she wants to denote the numbers, to assign the numbers to these categories. Obviously, here you can see that you can arrange these values in ascending or descending orders as per their values. But there is no sense to apply addition or subtraction on these values. You would get insignificant values. There would be no significance of those values. If you will add 1 and 3 or 3 or 4, nothing meaningful would come out. So that's why in ordinal scale, yes, we can arrange the values in ascending or descending orders, but none of the mathematical operators can be applied. Okay, now let's discuss about the characteristics of ordinal scale. So here, as I have told you, that ranks we can assign, okay, which can be arranged in ascending or descending order. And since the numbers of this scale have only a rank meaning, the appropriate measure of central tendency is the median. So, if we want to calculate measure of central tendency of an ordinal data, so the median would be appropriate measures of central tendency. Now, the next is the percentile or quartile measures is used for measuring dispersion. So in case of ordering scale, ordinal scale, definitely we can find out dispersion in terms of percentile deviation or quartile deviation. Correlations also can be find out, but these are restricted. Correlations are restricted for finding rank order methods, like rank correlation coefficient we can find in case of ordinal data. And for ordinal data, non-parametric methods are there, like Mann-Whitney test, rank order test. So many other uh, tests for testing hypotheses are there, and those are non-parametrical tests. So these were the characteristics of ordinal data. Let's move further. Here I have given you two examples as well to understand ordinal data in better way. Let's discuss about the interval scale. This is the third type of scale, measures of scale. So we can some in some situations we can have information about the temperatures, IQ levels, okay, pH levels of any liquid. So such informations can be categorized in interval scale data. And the most important characteristic of interval scale is there is no absolute zero. In interval scale case, we have an arbitrary zero. Interval scales can have an arbitrary zero, but it is not possible to determine for them what may be called as the absolute zero or a unique origin. The primary limitations of the interval scale is the lack of a true zero. Here I have taken an example of temperature. The Fahrenheit scale is an example of an interval scale and shows similarities in what one can and cannot do with it. One can say that an increase in temperature from 30 degree to 40 degree involves the same increase in temperature as an increase from 60 degree to 70 degree. But one cannot say that the temperature of 60 degree is twice as warm as the temperature of 30 degree, because both numbers are dependent on the fact that the zero on the scale is set arbitrarily as the temperature of freezing point of water. The ratio of the two temperatures 30 degree and 60 degree means nothing, because zero is an arbitrary point. So here we come to know that addition and subtraction we can apply as in mathematical operations on interval scale, but division and multiplication cannot be applied on interval scale data. Here I have given you examples like IQ level, pH level, dates, time, temperature. These all are the examples of interval data. And if we talk about characteristics of interval data, interval scales provide more powerful measurement than ordinal scales. For interval scale also incorporates the concept of equality of interval. Mean is the appropriate measure of central tendency. Yes, in interval data, we can definitely find mean as an average or measure of central tendency. Standard deviation is the most widely used measure of dispersion. So in this case, in case of interval data, definitely we can calculate standard deviation as a measure of dispersion. Product movement correlation techniques are appropriate. So in interval data, we can find correlation as well. Test for statistical significance are t-test and f-test. So here in interval data, we can apply t-test and f-test for testing the hypothesis. Let's move to the ratio scale. So here ratio scale is actually nothing but the numerical data, and examples can be the difference between 10 minutes and 15 minutes is the same as the difference between 25 and 30 minutes, and 30 minutes is twice as long as 50 minutes. It means here we can apply all the four mathematical operators: addition, subtraction, multiplication, division. All the four mathematical operators can be applied in case we have collected the information as ratio scale, on the scale of ratio. And as I have said already that ratio scale means we have collected the information numerically. Like if you have asked about the salary, of age, about weight, okay, if you are collecting data of distances, so these all informations are measured on ratio scale. I hope that you are able to understand that what does it mean by ratio scale. Now let's come to the characteristics of ratio scale. Ratio scale represents the actual amount of variables. For example, measures of physical dimensions such as weight, height, distance, etc. Second characteristics is all statistical techniques are unable with ratio scales, are usable, sorry, techniques are usable with ratio scales, and all manipulations that one can carry out with real numbers can also be carried out with ratio scale values, because it is pure numerical data. That's why all the statistical techniques can be applied except non-parametric methods. Multiplication and division can be used with this scale. Geometric and harmonic mean can be used as measure of central tendency, and coefficients of variation may also be calculated. One more thing which is not included as characteristics of ratio scale is that in ratio scale we can apply on all kind of parametric tests. So this was all about four types of measures of scales. By discussing about these scales, we come to know about that which appropriate statistical technique can be applied in different cases. Here I have made a table uh, to understand the scales of measurement in at a glance. You can easily understand, like label are can be applied in case of nominal, ordinal, interval or ratio scale data, and the orders of the values can be made in ordinal, interval, ratio in all kind of data, or measurable differences can be calculated in case of interval and ratio data only, and true zero starting point exists only in case of ratio scale. So thank you so much, wish you all the best, bye bye.